Okay, so today we're going to start 2.3, the composition of functions. So we talked previously about the algebra of functions, and composition is a new operation. We normally have plus, multiply, add, divide. This composition is a new symbol. So that little mini circle means composition. So let's go ahead and jump straight into an example. If I give you two different functions, f of x equals, let's do in this case 3x minus 1, and then let's say g of x is equal to 4x squared, it's supposed to be 4, sorry, plus 1. The question would be to find the following. So I can talk about a few different composition. It's a new operation, like I said, so not add, subtract, multiply, or divide, but it's a new one, composition. So the notation would be f composed of g. That little mini circle means composed of. And in this case, I'm asking you to find f composed of g of 2. And as we saw before, the definition is f of g of 2. So you're doing sort of an inside function and then an outside function. So g of x is our inside function, so I'll plug 2 into g of x, and that would give me 4 times 2 squared minus 1. Simplify that out just like you would normally. The notation is pretty important though, so really we have not dealt with the function f yet, so that f is still there, so make sure you keep that f there. So when you simplify the inside function, the outside function stays. You'll deal with that one last. So we go ahead and have 4 times 2 squared plus 1, which gives you 4 times 4, which is 16, plus 1 gives you 17. So that'll now turn into f of 17. Now you plug this into the function f. You don't plug 2 into the function f. You plug 17 into the function f. So then you look at f and you see where those x's are, and we're going to replace those x's with 17. So that becomes 3 times 17 minus 1. And then we simplify that, and that should equal 50. Okay, excellent. So there's that example for the composition. Let's do another one. Let's do a part B. Those same two functions, so keep in mind those exact same two functions. Let's just do it backwards. G composed of f of 0. So let's think about that. And again, the definition is now g of f of 0. In this case, f is our inside function, so now we've got f to be the inside function. So we're plugging 0 into f. So that gives me 3 times 0 minus 1. And then you simplify that the same way you would all the other ones. That becomes g of negative 1. Now it's the negative 1 that you plug into the function g. So then you take that negative 1, the result of the first simplification, to plug it into that g function. So 4 times negative 1 squared plus 1 should become 5, once that's all simplified. All right, so there's our composition functions. It's real quite simple when there's numbers involved, but the next step would then be to leave it as a variable and actually just compose two functions and leave them as a function. So let me go ahead and give you two new functions. This will be our example 2. I have f of x equals x over 1 minus x, and then I'll have g of x equals 3 over x plus 2. That was supposed to be a plus. There we go. So now the question is going to ask you to find f composed of g of x. So not plugging in a number, but leaving it as just x. And find the domain. Sorry, that was erased too quickly. And find the domain, of course. So f composed of g of x is, by definition, f of g of x. So that's that definition again. So now what we're going to do is, instead of g of x, I'm going to replace it with what g of x is. And g of x is the function 3 over x plus 2. So you're literally replacing that entire g of x in those parentheses with what the function is, which is 3 over x plus 2. And then it's always good to kind of go back and look, okay, so now I have what my g of x is. I need to put that into my f of x. So I'm going to rewrite, what was my function f of x? What is it that we had for f of x? It was x over 1 minus x. So now I have f of this big parentheses, 3 over nonsense. And all of that parentheses is going to replace all of the original x's in your function f of x. So I have in parentheses 3 over x plus 2, then all over 1 minus in parentheses 3 over x plus 2. So notice that comparison. It was the x's from the function f that got replaced with those parentheses. Once you do that, that's sort of the trickiest part. The next step is all simplification. So everything else is just to simplify this. Same way we did with the difference quotient, find the LCD to simplify out all of your fractions. In this case, it's nice. The LCD is just one denominator, so that's x plus 2. Multiply everything on top by the x plus 2. Multiply everything on bottom by the x plus 2. Just don't forget to do everything, so that 1 is also going to get the x plus 2. Take your time when you're simplifying. I know it's a little bit faster in this video, and I apologize, but make sure you take your time. Pause this video if you need to spend some time. Take a minute and simplify it on your own. Few of the fractions are going to cancel. You're going to end up with 3 on top. You're going to end up with a 1 times an x plus 2, and then minus just another 3 on the other side where a lot of things canceled out. Distribute that 1. It's real simple to do that because it's just 1. Combine all of your like terms, so on the denominator you'll just have one simplified version of x minus 1, once everything's simplified out. So that is the answer to the composition. So that is how we found f composed of g of x. It's 3 over x minus 1. Notice what it gave you is a new function. You compose two functions, you get a new function. So here I've got all of them written out here, your f of x, your g of x, and then your f composed of g. Our question was to find the domain. So how do we find the domain? And it's real simple. There's only 2 steps. First of all, you look at the inside function, g of x. What could x not be? Negative 2. Second step, you look at your simplified composition, what you just went through all that work of doing. And what could x not be there? 1. So again, your inside function, and then also your final simplified composition. You just look at those two to figure out what x could not be. And then your domain, x could not be negative 2, and x could not be 1. Those were our 2 answers. That's how you write that as that interval notation. All right, let me say that one more time for the domain. You're going to look at the inside function, which in this case was g of x, and you're going to look at then the final simplified composition, which was the f composed of g. Remember, that's your domain. Ta-da!